Hi, everybody. Raise your hand if you consider yourself a Java developer or no Java. Okay. And raise your hand if you're a Groovy developer or no Groovy. All right, a few people. For those of you who do know Groovy, we're going to finger vote. 5, I know everything about Groovy, and 1, I sort of heard about it and I'm marginally functional. What do you guys consider yourselves? Oh, good, no 5s, because if you were at 5, you'd be in the wrong room and way overqualified for this talk. About me. I'm mostly a Java developer. I've written 3 books about Java 8, and I'm now upgrading them for Java 11. I also use a good amount of Groovy at my job because Groovy is a JVM language. I work on a DevOps or tooling team, which means we do a ton of security and reporting and automation around DevOps tools like Nexus and Jenkins. Those 2 in particular come with a Groovy Scripting console, which means the solution to many problems is Groovy. It's great. You don't have to compile everything, and you don't have to do it by hand. We're going to be covering some basics of Groovy, the syntax and the idioms, and most importantly, how it differs from Java or a Java mental model, since that's where many of us are coming from. We'll then see some techniques for using it in those tools of Nexus and Jenkins, and if there's time at the end, we'll do a live demo of those 2 tools. I did this presentation that you're seeing here along with a 2-hour hands-on lab at Oracle Code 1 in San Francisco. This is the URL for that lab. I obviously don't expect you to be doing the lab while I'm talking. You're here live. You're totally going to want to pay attention to this. But if you want to on your home machine at some point in the future, it's a great way to get started and get hands-on experience with these scripting tools. The only requirement is that you have a machine that can run Docker. For all of those who are still on Windows 7, it's time to upgrade your computer. In that lab, we cover using Nexus and Jenkins with Groovy, and then we have a bonus of using Java to write a sonar rule to check the quality of a sample application. It's a really cute app. There's teams, and there's the open ospreys and the secret sea lions, and they can't see each other's stuff. It's a lab with a plot. Starting out with Groovy, and the syntax and the idioms. As I mentioned, Groovy is a JVM language. What you might not know is that in some way, Groovy is a superset of Java. Almost anything that compiles in Java will also run in Groovy. This is great when you're learning Groovy because you don't have to look anything up. If you're not sure how to do something, you write it in Java. You then show it to your colleagues who know Groovy, who sort of cringe at, like, really? Wrote it that way? And over time, you start to write code that looks more and more like proper Groovy, and more importantly, start to think that way. I started using Groovy streams and functional programming before I did in Java, and I could see my evolution from I'm going to write a loop, and I'm going to translate it to use proper functional programming, to actually thinking that way. But it happened because I was able to have that slow transition. Taking a look, as I said, you can write Java. This is a perfectly good Java syntax. Java syntax tells us we have an int, it declares it to a value, it has a semicolon. Again, if this is news to you, you're in the wrong room because I assume you know Java. But you can start making it more Groovy-like. The first thing you can do is you can drop the semicolon. Semicolons are redundant in Groovy. One less thing to do. We don't have to type semicolons everywhere. You can also use def instead of the type. It's not like var. Def is a true scripting language def. You can decide later in your program that next year is a string or a Boolean or whatever you want it to be. Please don't. That's a bit confusing, but you can. And with int, there's really no point. Def is still 3 characters. But if your class name is long, which happens a lot when you're doing scripting in Nexus and Groovy, because we have class names like role manager, there's a good mouthful where def starts to become helpful. And again, it's one less thing that you need to look up. The next thing is we've got our Java strings. This is a bit of Groovy code that uses a Java string. This is your first gotcha if you're a Java developer, because you're looking at this thinking that's not a string, that's a malformed character. In Groovy, this is a string. Most importantly, it's a string that functions in a way similar to Java strings. We know what a Java string is like. We can concatenate with it. We can call various methods on it. I'll get back to the one difference later, but for the most part, this is a Java string. There's nothing funky about it. If I print out a Java string, what do I expect to happen? Anybody? You all said you were Java developers. What does this print?
Here, $city.
Right. This prints here $city because we told it to. It's a string. We can also have, is that a double quote? I can't read it. Yes, that is a double quote. A double quoted string, which is a G string or a Groovy string, that has extra properties. In particular, the one we care about is string interpolation. This is where it starts to look like Python or other languages, where it sees the $sign and says, ooh, a variable or expression, let me evaluate it and print out the result. This one prints here in New York City. And that's your first gotcha in the space of Java versus Groovy programming, that you have to pay attention to what type of string it is so that you know what behavior you get. Because I switch back and forth between Java and Groovy so frequently, I got used to it. For a good while, I was using the wrong string and puzzling over why it didn't work. It was fun when you went from Groovy to Java and your code didn't even compile. But it's a string. I know, because I use the single quotes. Okay, so we've got our example here. You can also have expressions. If you use $sign and the squigglies, you can put a method call or a variable or property in there, and it'll evaluate that for me. So I can tell that my city thing really is a Java-based string, just like I told you. Java lang string, that's been the class name of string since Java 1. Nothing new and shiny there. Groovy also beat Java to having a multi-line string. I know, it's coming eventually. When I wrote this, it was going to be in Java 13, but alas, now it's not. Nobody has announced that it's going to be in Java 14, so this is not a product announcement. It's a hope. I like this feature. I can't wait for it to be in Java, so maybe it'll be in 14, maybe it'll be in 15. We'll find out. But in Groovy, it's here now. Woohoo! You can use a single string and have it repeat 3 times, or you can use a double string and have it repeat 3 times. Either way, that's saying I'm going to have a multi-line string, and everything that appears until I have that string delimiter another 3 times means I want that included in my string. In this case, we've got double quotes. We've got a multi-line Groovy string, which means that $sign name will be interpolated and print out my name. Convenient. We can do the same thing with a Java string. This is going to print out literally $sign name because it's a Java string and not a Groovy string. But technically speaking, we do have multi-line Java strings. The only problem is that they're in Groovy and not Java. We're getting there. Maybe it'll be 14. Another difference between Groovy and Java is properties. This is some valid Java code, except for the fact that I'm using a Java string with single quotes. I'm creating a string, a Java string. I'm calling get bytes on it, and we know what that does. That prints out an array of bytes. In Groovy, I can just say bytes, and it will call get bytes for me. It'll say, oh, you have a property, and I see there's a getter, and all is good. I'm going to take care of calling that for you. That means there's a lot less typing. And in the space of things like Nexus and Jenkins, where you have a ton of chaining, give me the job and the latest build of the job and the timestamp of the latest job. Separating these with dots just makes the code a lot easier to read because I can focus on what I'm trying to get and not my getters and my myriad of parentheses to make method calls. You might have noticed earlier I danced a little bit around the behaving exactly like a Java string. It behaves exactly like a Java string except for equals. We all remember when we were new to Java and they said, don't call equals on strings. It won't work except for when it will. And you don't want to get involved in that mess because you have to know about the string pool and how the code runs to know if equals worked. And egads, that doesn't work. In Groovy, we have our string here. Monday is a Java string. It's got our single quotes. Next Monday is also a Java string. It uses a constructor. And as we learned in Java 101, these are different strings because I use the constructor. If I use equal on Monday and next Monday in Java, it'll return false. Tuesday is also a Java string. And if I compare Monday and Tuesday, they're going to return false because they're completely different strings. Now I can do some print lines. If I check if Monday is null, that's clearly going to be false. Monday is not null. Monday is Monday. I can do it in both directions. Nothing new and exciting here. I can compare Monday and Tuesday. Again, that's going to be false. Or I can compare Monday and next Monday. And in Groovy, this will return true. Groovy takes care of equal and has it work the way you wish it would work rather than the way it actually works in Java. So that's your second gotcha if you're a Java developer. Equal doesn't do the same thing. It does something better. Now, you may be wondering about what's with all those nulls. I know Monday isn't null. It's Monday. I have it there to show that that still works in Groovy, which means it's not just saying Monday equal next Monday translates to Monday dot equals parentheses next Monday. It's taking care of the nulls for us and working the way you would expect an operator to work. Convenient. All right, I keep talking about this truth concept. Groovy handles truth in a way that's similar to many other scripting languages. Null, empty string, and empty list are all false if you use them, which means I can say if list and have it mean something. I don't have to write if list equal null or list is empty in order to express that I care about an empty list in a safe way. Groovy takes care of that, which allows you to write some code that's more concise than code you might have ordinarily written. A one-character string, a one-character list, an object, your name, your dog, all of those things will return true because they're objects and clearly not null. Our next operator is the Elvis operator. Groovy has an operator. The trick is you turn your head and it looks like Elvis's haircut. The Elvis operator is a null-safe operator. Think about switch statements, ternary operators, but heavily abbreviated. What this code is doing is it's calling the first method, Jenkins instance get item by full name. Ideally, we have a job, and it matches that full name. It gets returned. It has a run. We get the last build. It has a timestamp. We call the timestamp, and we get the time on the timestamp, and we get the last run. In a not-so-ideal world, the job doesn't exist. There was no last build. It exists, but it never ran. There was a last build, but somehow it got corrupted along the way and it doesn't have a timestamp. All of those scenarios are handled by the Elvis operator because if any time the Elvis operator sees a null, it says, okay, don't worry about it. I won't call the rest of the stuff. I'll just return null for you, which means I can guarantee this is going to print either null or the time of the last build, which is exactly what I want. And I can do it in a way that doesn't have a lot of ceremony. Imagine how many if statements you would need in order to handle this in Java. It'd be 3, right? You'd have to make sure each of those wasn't null in order to do anything, and now the code's hard to read and ugly. Yeah. Our next thing in Groovy, which is syntactic sugar, is optional parentheses. In many cases, you don't need the parentheses in Groovy, whereas you would in Java. So I can call char at without parentheses. 1 is automatically the method parameter. It's useful whenever there's no ambiguity. If Groovy doesn't know what to do without the parentheses, it will make you add them. Most of the time, you don't need the parentheses, and that's good. Makes writing the code a tiny bit easier. Next up, we have ArrayList. We're all comfortable with ArrayList, right? Basic data structure, common in Java. Excellent. So we've got our code here that uses ArrayList. We can put 2 things in the array using an array initializer. We can add an element to the end of an array, just like we were concatenating with a file in Unix. We can print the class that's array, and we can get the array index. And all of this looks just like Java, doesn't it? I mean, I've been able to do that since never. Well, 2 of them look like Java. And ArrayList actually does all of this stuff in Groovy. I like to think of it as ArrayList++. When you're working in Groovy, an ArrayList has all the properties that an ArrayList in Java has. So the methods you know and love are still there. But it also has the things you would like to have in a scripting language or just in general, which means I can define things like I'm writing in a language like Python or Perl, and I can concatenate with that operator just like I'm in Python or Perl. So we've made the array list better, but it's still an array list. And you can see when I called get class, it does still say array list. So if I'm expecting to call contains or filter or for each or any of that stuff, it's still there, which is good. Since ArrayList is more powerful, it has other features that you might expect to have in a scripting language. We start out with our ArrayList, which has 3 things in it, because I elegantly added candy to the end. It's a good thing it's after lunch and right before the break, since I'm taunting you with candy. I can print the negative first element of the array. If you're familiar with other scripting languages, that means go to the back of the array and tell me what's last. If you tried that in Java, you'd get a nice exception. If you try it in Groovy, you actually get an answer. I can print the minimum value of the list. That's something that Java doesn't do. Print the maximum. You can guess what that does. I can sort the list in place. I can do that in Java, but I have to call collections.sort. In Groovy, I get to do it as if it's an API on the ArrayList object. And you can see that sorting it did, in fact, sort that. This is true for maps and sets as well. There's convenient syntax that makes it feel more like a scripting language. And that's fair, because it is a scripting language. It should feel like a scripting language. Next up is metadata. I can print out the methods that are available to me. And if Chandra's still here, yes, I can do this with reflection, but it's a lot more than one line of code. In Groovy, it's one line of code to print out all the methods. And thanks to chaining, I can do more than that. I can print out all the methods alphabetically by name and remove the duplicate ones. So methods will give me all the method signatures. That mess of code, the last name, will just give me the method names in a human readable format. I use this a lot when I'm working in Jenkins because it's easier for me to print out the methods that are available on the objects that I'm on than to go find the Java doc and find the methods there. Next up, we have streams and lambdas. Yeah, we've had those since Java 8. They should be old news by now. They work a little differently in Groovy. This is something that frustrates me because Groovy had them first, and I feel like Java could have come a little closer to Groovy than actually happened. If we wanted to write code in Java to print out the elements that are greater than or equal to 5, this is what it looks like. And I know it would be better if it was on different lines, but I need to show something else on the screen, so we're just going to pretend this is nice and readable. This is that same code in Groovy. In Groovy, I use grep instead of filter. Took me a while to remember both of those, and then I'd switch to JavaScript and I'd forget everything again. But grep is saying, OK, find the ones that meet this criteria. I don't need the extra parens, as we learned with charat. Parens are optional when we don't need them. So grep is taking the place of filter. I don't need a for each because grep is immediately returning me a list, so I can just print the list. And I don't need the stream because that's just redundant. That's telling us that we're going to use a stream in front of a list, as Venkat taught us earlier today. It's a lot more concise way of expressing the same thing. It's also nice to not have to constantly switch back and forth between collections and lists in your head. That's a nice convenience. You can make it even shorter, though. For those of you who are at maybe a 3 on the Groovy scale, you're probably wondering why I keep talking about num. I did it because we're all Java developers and we're used to seeing lambdas that begin with a variable. In Groovy, you don't need to do that, though. In Groovy, you automatically get a variable. It's named IT, and you can use it in the Lambda automatically. If you're talking to someone who knows Groovy, they're going to write this code as grep IT is greater than or equal to 5, because everyone knows that IT is the thing that we're looping through in the list, and you don't need to write it. We've made the code a lot shorter. The first example in Java barely fit on 2 lines. The last example on the page doesn't even take up half a line. I could cram another half a bit of code there and do 2 things, but I won't. That would be mean. Taking a look at what we learned together, we can see that we can write a lot of powerful code in a very short space. 10.1 creates a range from 10 to 1. That's probably not terribly surprising. Each is like for each. It goes through that. And we learned that IT is our automatic loop variable. So I can blast off some space in 2 lines using all of the Groovy syntax that I've been showing off here. A little reference for those of us who are more used to Java. Filter and grep are mostly the same thing. Map and collect, for each and for. They're pretty much one-to-one mappings. Take is like limit. I want to take the first 5 elements that come in from my stream or list. Distinct and unique, again, just different names for the sake of being different in Java. Any match and all match are named any and every, and find first is named find. And again, Groovy had this first, so there was no good reason Java had to be different as far as I can tell. And I know that's a very Groovy-centric view of the world. I'm sure that Kotlin and other languages feel the same way when things don't match at their end. But this is the set of names in both, and it's a handy reference. The nice thing is when you do it wrong and it doesn't work, it's really easy to see what you did wrong. Like, oh, yeah, there's no grep method in Java. OK, well, I'll type filter and I'll move on with my life. Another big difference in the space of streams is these Groovy things that I keep calling functional programming and streams are not streams. They're just methods. In particular, Groovy does not use lazy operations, lazy evaluation. So if I have that million record array list like Venkat was talking about earlier, Groovy is going through all million of those elements. Java is not. I can help fix things if I use operators like take to say I only want the first bunch, but it's still going to be doing a lot more work than Java to do the same thing. That said, I don't have a stream. I just have a method that I'm calling. And for the purposes of what I'm doing, it's fine. If I'm dealing with 100,000 rows, it's a lot. So the fact that it's going to evaluate them all is fine. And most of the time, I wanted them all evaluated anyway because I'm writing a report on all of the data that's in the system. Lazy evaluation doesn't help much when you need all the data. Our next change is functions. In this case, I've created a variable without a type, not even a def. That means that it's going to have a different scope, and my functions will be able to access it. To write my function, I can write a really bare bones function. I use def to say I have a thing here. I don't have to give the variable a type. I can just use num as if it's a thing. And I don't have to type return. I can, because everything that's valid in Java is also valid in Groovy. But I can also just say num plus increment by, and it will automatically get returned because it's the last statement in the function. It allows you to write some really clear, concise code. It also makes it important not to have your functions go on forever, so it's not hard to understand what's going on there. Another thing that Groovy has that I really like is NameParameters. Automatically, you get one constructor, and then you can create a map and say what you want to set. In my case, I'm setting the name of the selector and the description to packages. This is helpful when you have a lot of potential constructors. You don't have to create those 20 constructors of all the permutations. You don't have to worry about, well, if I have a constructor with 3 strings, what order they go in, the caller is going to mess that up. Maybe I need a factory, but then the factory is going to have 3 parameters, and the caller is going to mess that up. So I guess I need a builder. Right? We can just avoid all of that by saying, okay, well, the constructor is going to take all of the things it needs as a map, and now I have everything I need, and I don't have any worries about intent. If I mess up name and descriptor, I mean, that's on me, right? I typed it in. I should be able to get this right. For those of you who are looking to learn more about Groovy, I strongly recommend the Groovy Style Guide. It's really useful for us Java developers who write Groovy that looks like Java. The Groovy documentation on collections is interesting. It covers the ArrayList++ bit that I made up, along with all of the methods that they added. And of course, there's the Groovy docs themselves. They look just like the Java docs, except they cover the Groovy additions. All 3 of these are really useful to have as a reference, and the first one is interesting to have as a read as well. I pause and look around to make sure that everyone's done taking a picture of the screen, and we're good. That brings us to the second part of the presentation, actually using Groovy in Jenkins and Nexus. If you're using Jenkins or Nexus, you're going to find this really cool. If not, consider it a case study of how things could work. The concepts translate to lots of things, so it's still interesting. This is the Groovy Scripting console in Jenkins. It's actually a legitimate page of the admin console that you go to. It's a giant text area, and you can type in Groovy. So Groovy Scripting console is good advertising for what this thing is. We like it a lot. It means I don't have to get SSH access to the server to do things. It's so much faster to go to a browser and type in Jenkins/script and then my command. I've gotten really good at running Unix commands via Groovy. You do quote, your Unix command, end quote, dot execute, dot text, and it runs the Unix command for you and prints out the result. I know that by heart, so I don't have to check out an account and open PuTTY and SSH to a server just to check how much disk space we have. Saves me a lot of time. I can print stuff out. I can ask Groovy what version I'm on, and it will tell me. This happens to be the version on my home computer. I can also create jobs. I can tell my job that I want it to have a Groovy section, and it'll run. Again, I'm printing out the Groovy version number. I run my Jenkins job, and it shows up. This is good for automation. Maybe I want to check something, right? I've told my users you must have an email in all jobs, so we know who you are, and we can tell you when your job fails, and they forgot. So I can have Jenkins take care of telling me. You might notice that the word Hudson is in this, as is Jenkins. Jenkins and Hudson split, I want to say like 8 years ago. It's been a really long time. But the source code is older than that, so there's still a bunch of references to Hudson sprinkled in. Consider it the same thing by now. Unless you're a Hudson developer, then it's not the same thing at all. You can also execute a system Groovy script. System Groovy scripts are different than user Groovy scripts. A system Groovy script in a job can do anything that you could do in that giant text area. It can access all the system properties. It's an admin. A Groovy script that's not a system script is something that can be run by a developer just running a build. It can access the build properties. It can access its own logic, but it's a lot less powerful. When I'm running a regular user Groovy script, I can pick the version of Groovy that I want. When I'm running a system Groovy script, I can't. And that makes sense, because if it's running as admin, it has to use the same version of Groovy that Jenkins is using for anything to work. So how do you find out what methods to call in order to get any of this automation done? Well, there's 3 ways. In theory, the best way is to use the Java doc. That's probably true of everything. The problem with the Java doc is it's not in one place. There's the Jenkins Java doc, and then there's all of the individual plugins Java doc. It's all available via these links, but it's a lot of clicking to get where we're going, and I'm a lazy developer, so I often don't do this. What I do is try to find it myself, and then if I can't, I sort of grumble and go back to the Java doc. You can use Groovy, as I showed earlier, and have Groovy tell you what methods are available to you. I find that the most convenient. Or you can Google. There's a ton of Jenkins scripts out there of people who have already done what you need or similar things, and then you don't need to write the script at all or hunt down the APIs. You just get to start out with what someone else has done. I've got a bit of sample code here, something that's pretty common to do in Jenkins. This creates an account. I get an instance of Jenkins. Jenkins is a singleton, so it can do everything there. Then I ask Jenkins to give me the security realm, and I add Olivia to the realm. I now have an account with username Olivia and password Olivia. Not very secure, so the first thing Olivia ought to do is change her password. But I can automate all of the creation of an environment. This is useful whether you're in a Docker or Kubernetes container or you're just trying to automate scripting so you don't have to keep doing the same thing by hand. Jenkins also supports Groovy for pipelines. Pipelines are a type of job. To say, okay, well, I want to compile, and then I want to build, and then I want to put in Nexus, and oh, by the way, if it's Tuesday, we do audits, and we want to upload this report somewhere else. Jenkins comes with a pipeline syntax helper. There's a bunch of pull downs which will show you what sample operations look like so that you're not having to start from scratch. It can also take an existing legacy job and turn it into a pipeline. It's not 100%, but I would say it does about 75% of the work. And again, lazy developer, if Jenkins can do 75% of the work, I only have to do 25%. Seems like a good deal to me. I can put my Groovy script in a repository. In real life, that's what I do with it, so that it's version controlled, just like all my other source code. This is a sample of the Groovy code. It shows using passwords, and it shows uploading to Nexus. In particular, it shows a closure. We're all familiar with closures now from Lambdas. I have a block of code that knows how to use a credential and upload to Nexus with it. The problem with storing your source code in a repository is, unfortunately, you then have to deal with the script security plugin. The script security plugin is something that CloudBees made for Jenkins to protect Jenkins from running hostile code. Because if you get code off the internet, God knows what's in it. This is a great idea in principle. In practice, a lot of people have their Jenkins locked down so that only administrators or trusted parties can run Groovy scripts at all, which makes this feature really, really, really annoying. Because I can go into Jenkins as an admin, do anything I want, but then when I do that, store that same code in the repository and run it as a job, all of a sudden it's hostile code. I got to tell you, if I was trying to attack Jenkins, I wouldn't bother putting it in source code and creating a paper trail. That seems like a lot of unnecessary work to me. But the options of the script security plugin are you can approve each script manually. This is good if you have a small number of scripts and they're named. That's not my world. You can use the sandbox and whitelist APIs. This approach is the most common that I've seen because eventually you will run out of APIs. It's a while. Or you can use the authorized build plugin to run as an admin. The problem is you're now impersonating another user in order to run. And if you were concerned about security, that's another security problem. So, But it is still better overall than the alternatives. So one of these 3 options does get around the problem of the script security plugin if you don't have hostile users. Our next thing is how to use Groovy and Nexus. Nexus is a binary repository manager. That's where we store our jar files. And starting with Nexus 3, it also comes with scripting. Yes, it didn't in Nexus 2. This is a big improvement. It doesn't come with a nice text area where you can run whatever you want, but it does have tasks. And since you can run a task manually, that still allows you to run Groovy code completely through the UI. I go in and I create a task. I have a text area in that task where I list my Groovy code. We're back to hello, Oracle code 1. You can see I didn't change this from when I gave it originally. And we print out the version number. Great. Nexus comes with a bunch of built-in APIs. They're differently documented than the Jenkins ones, but that's okay. We've got the script API, and then we've got 4 other main APIs that you can use in order to do things. Blob stores are like repositories. They're where you store stuff. Repositories are repositories. Securities are users, that sort of thing. If you look at the documentation, there's these 4 objects that do everything you need to do. And then there's the secret 5th object. Looking at all the sample code on the internet, there's also this container object. It turns out the container object does lots of other useful stuff, because the container object can look up other objects. These 3 are the ones I use the most. And given how prevalent these 3 are, I'm not really sure why the container API is so secret. But just like Jenkins, the best way to find out how to write code is to Google for sample code so you know what APIs to use without having to look everything up. You can also set up your Eclipse or IntelliJ to reference this Groovy project, which I'll show when we get to the live demo section, which allows you to debug in and start looking at the APIs. Once I'm in the right area, I find that to be a nice way of finding out what to do. It's like, oh, okay, well, Content Selector API does what I need. Let me start looking at what's available in it, what objects does it return, what's available in that, and I can get most of what I need done that way. Saves me a lot of time. Okay, that was strange. Before I go on to the live demo, I wanted to check if there are any questions. I didn't hear the question. Say it again.
Java source. Can you embed a Java source code?
Can you embed Java source code in Groovy? Well, valid Java code is Groovy, so I'm going to say yes, but you wouldn't need to embed it. You would just write it.
As a block or just take it right in it?
I could write legitimate Java code. Like, I could write a for loop with a print line and some if statements and a collection and stuff and call it a Groovy file, and it is. So the answer to this is yes. As I get more experience, I sprinkle more Groovy in, and eventually it's all in Groovy. But you can run a legit Java thing through these Groovy consoles, because everything that's legitimate Java is legitimate Groovy too.
Take a Java file and run as a Groovy?
Mm-hmm. Yeah, as long as it's a program, right? So like I can take the contents of a main method and put it in. If I put in a class and it's just a class, Groovy is going to be like, what's this, right? Because Groovy is running. In these tools, Groovy is running it as a scripting language, so it doesn't know what a class is. But you can write some pretty elaborate things with classes. You can do inner classes in Groovy and reference things that way. And if you were writing a Groovy app, like in Grails, you can, of course, have Groovy classes. These tools are set up to do scripting, so they need a script. But yeah, you can write your script in Java and call it Groovy and be good. And I recommend that as a first step. If you don't already know Groovy, starting out with what you do know is a quick way to getting these tools to benefit you. And the more you're in them, the more you start to Groovify it and do better. Other questions? All right, demo time. Hey, my resolution changed between when my laptop was on my lap and just now. That's fun. All right. So I've got a project here that has some Nexus code in it. This is code that I used in that lab I did in San Francisco with the audience there, where we were setting up things according to a skit. And we can see that we've got this container class that I'd referenced. We pull it in, and we're able to do things there, including calling things on it like a list of roles. OK, well, what is this list of roles? Hey. All right, we're going to give that one more shot. OK, keyboard shortcuts aren't working. Great. That works. Huh. Isn't it fun when things work on your computer and then they don't work in front of people? This worked yesterday. Well, when I did it yesterday, what this did when I clicked on list roles was that it took me into the roles class so I could see what's going on. Let's try it with a different class. That was strange. I mean, I know why it happened. It happened because Groovy couldn't tell what authorization manager was because it was never declared anywhere, but it was weird that it worked yesterday. But all right, we'll use security. I can see for security what's available to me. I can do things like add a user or get a user. And as I was talking about earlier, well, what is this user thing? I can see a user object, what it has. This is very similar to what it has in the UI, which you would expect because this is the code that's being used behind the scenes of the Nexus UI. But I can see what's available to me, and I can see what I can call on it, which means when I want to do something like, oh, well, I want to edit somebody's status. Well, how do I do that? Okay, well, I'm looking for a method that has to do with status. And I see there is one, set user status. And it uses a user status, which it says is an enum. Okay, well, I can see what my choices are for an enum, and now I know exactly what to call. Once I figure it out once, of course, I've written it down and I have it in my code base, so now it's available to me forevermore, which is very convenient. And you can see that there's some patterns here. I'm getting the list of users and roles. I'm deleting the role if it's found. I'm adding it if it's new. I create an anonymous role. This is using that map syntax we saw before where I'm calling the default constructor, but I'm calling it with these settings. And you can see here why this is a useful thing. This is certainly not a simple constructor. I'm calling a whole bunch of fields, and I'm calling them with values that are by no means trivial. Privileges in particular is a list, but it's pretty easy to read this and see what's going on because I have the label there that says what my value is. So I find that to be useful. Same deal again with the selectors. And you can get a feel for this with scripting code that once you start doing it, you get patterns, just like when you start doing Java and you get idioms, which means it gets easier over time because you're not constantly looking up the language idioms, how to do things, what APIs to call, that sort of thing. I also have an example here in Jenkins, and then we'll get actually into the tools. In Jenkins, this is a job that creates a build pipeline. So a build pipeline is an XML file with some Groovy in it. This is sort of ugly. I got it by copying and pasting from an existing job. But inside of it is the Groovy that represents that pipeline. And I can see what it actually does here. Like, OK, I'm doing things we saw with credentials before. We saw checkout from GitHub before. And then we get into our Groovy code where we're doing things like creating a job and running it. That's all cool. Let's take a look at what this looks like in a browser. I'm going to refresh both my browser tabs because I'm positive I've been talking long enough for this to have timed out. And let's log in. This is running on a Docker container. I set up a separate Docker container yesterday so that this would be clean, which is why my password is now admin123. I did not set anything up in it, so you could see that I didn't stage anything in advance. And I want to run a task that does some Groovy code. So I'm going to create a new task, and I'm going to execute a script. This is Oracle code. In Nexus, you need to use log info for it to show up in the log file. Print line goes to an obscure file on disk, and since I don't want to log into the Docker container to find it, that wouldn't be awkward. Oracle code. Okay, let's try to do something that actually shows this is running code, preferably in Groovy. Rand equal new. Actually, random does this, right? Math dot. I forgot. Forgot the code for random. Nuts. New random. I think it's random.nextInt, but we'll find out. Worst thing is I get a syntax error, and you get to see what that looks like. Okay, so I'm going to run my Groovy script. And it's telling me that it's running. And then it tells me I had an error, which is not surprising because I wasn't sure about the syntax. But that's OK. And then I need to use the logger. Really? Log viewer. And it's telling me that logger.info is wrong, which is not what I was expecting to happen. But that's OK. You got to see an error message. Tasks. Let's get rid of this. That looks fine to me. I'm sure I made a stupid typo because live coding is hard and scary. OK, so that time it worked. It was the parentheses. Remember what I said before about parentheses being optional until they're not? This is how you find out that they're not, when it doesn't work. I'm not quite sure why that didn't work. It looked like a very straightforward logger call to me, but not a Groovy expert, so be it. But I've got this in my log. And you can see that I can write arbitrary, complicated stuff there. The other thing that's worth noting about Nexus is that Nexus has a bunch of REST APIs. One of them is about the tasks. So you can upload these tasks or jobs in order to have things run. You can also upload scripts directly. Tasks are the stuff I'm doing through the UI. If I'm just doing a Groovy script programmatically, I'll use this API in order to update the Groovy script and run the Groovy script. We wrote in a nice little framework at work where we have the Groovy scripts in GitHub. GitHub runs Jenkins. Jenkins checks to see if there are any new scripts. If so, it uploads them, and then we can call everything as if it's a Java REST API. We've essentially insulated ourselves from this. Taking a look at the Jenkins side of things, again, we're in a Docker container, so I have a default password. We've got ourselves the scripting console. I always type /script up here to get to it, so it feels weird going to it the long way. But when you use something enough, you know the URL. So let's Jenkins. This is not valid code. I want to show something. Okay. So it's told me that Jenkins' full name is not a valid class. What I really like about Jenkins is it suggests stuff for you. So it's like, oh, maybe you meant get full name. I actually didn't, so I'm going to give it another clue. Like, oh, maybe you meant get full name. All right, so it's giving me ideas. The reason it did that was because I didn't put instance. So if I put instance, now I have a different API and a different collection of things, and really, it's still on full name? Get item by name. All right, now I finally got what I was trying to get it to show you before, which is it suggested two things you might actually reasonably want, which are get item by full name. That's the API that I showed in the presentation slides before. That's how you get a Jenkins job in order to start progress, in order to get anything to happen. So really useful. This is the other reason I so infrequently look at the Java doc. Having done it enough times, I'm usually close enough that I can get enough of what I need done that I can get Jenkins to tell me the rest and call it a victory. Check my notes for what else I wanted to show. Okay, so I'm going to create a new item, Oracle code, and I'm going to create a pipeline. Pipeline. It lets me try a sample pipeline. So if I want to see what the simplest pipeline on earth is, it generated the Groovy code. And I know what you're thinking. This looks nothing like Groovy code. The reason it doesn't look like Groovy code is because so much is optional. Parens are optional. Scoping is optional. So we've essentially created a little method enclosure here that prints hello world at the appropriate time. But I haven't had to think about that because it generated the infrastructure for me. This is a longer pipeline, and again, we can see there's stuff going on with scope. Here it's starting to look a little more like a method. It's like, oh, okay, that's a method that has a parameter. But you can see once you get in the weeds of this, it does start to look like Java or Groovy code. I've got an if statement. We're going to recognize that as programming. And I've got a method call with the optional parentheses. It's like, okay, so there's a method called shell. And then there's a method with the optional parentheses. So there's a method called bat. And I can see if I wanted to control things, I could add my own logic here. I could read from a file. I could add looping. I can do anything I want because I'm a programmer. That's what gives these tools so much power. They're development tools, but they're written for developers to use. And when we're developers and have a problem, the solution, of course, is always code. It's really nice that these tools have made it that we can facilitate that writing of code to make them do anything we want. And now we have a whole minute for final questions. Hey, I asked if people had questions before. We had more than a minute then. Okay, I leave you to the break. Thank you.